welcome everybody to this topic, which is called Business Models and Possible Applications for Air Taxis and eVTOLs. I would like to introduce this a little bit. I'm Jan Delfs from DLR, as I just said. I am working for the Institute of Aerodynamics and Flow Technology in Braunschweig, and I'm heading the Department of Aeroacoustics or Technical Acoustics. But this is not very important today. I'm a layman. I'm just moderating this discussion. I will introduce the participants in a minute, but before, let me say a few words to introduce you into the topic we want to talk about today. In October 2016, Uber Elevate, which is a subdivision of the taxi service provider Uber, published a white paper. I believe it was a very good and important paper. It was called Fast Forwarding to a Future of On-Demand Urban Air Transportation. And this white paper in 2016 was directly followed by a first workshop Uber organized in Dallas in 2017 in April, where I happened to be and had the chance to participate. In this white paper and also in this workshop, there was more or less clear that air taxi services require VTOL. What is VTOL? VTOL is vertical takeoff and landing, because in near cities or in cities we do not have large runways, or you have no space, so you have to be able to start and land vertically. And you may ask yourself immediately, yeah, we have things that fly vertically, that's called helicopters. Why do we need anything else? That's all existing. And well, I would just say and claim helicopters are expensive, very expensive. They are very loud. There's little public acceptance. Because when there are air taxi services with helicopters, this is sort of perceived as taxis for elites in a way. And it's also not particularly perceived as a very green form of transportation. So you can ask yourself, what is new? What is new? It is new that we have high-performance electric motors and high-performance batteries today. And this leads to eVTOLs. That is, the E stands, of course, for electrically driven vertical takeoff and landing. And the very question arises whether this is really a game changer on this taxi idea, this concept of having taxis to move people around through the air. And this white paper of Uber outlined a set of requirements, and that's why I think it is a good one. Requirements to the viability of urban air mobility. What are the requirements you have to fulfill in order to make such a system running or realistic? And this is, so to speak, the background to what we will talk about. I think we will take this Uber white paper as a kind of backbone, because it's really very structured and very well written. And before we do that, I would like to introduce the participants to this discussion. I would like to start with Georg Garnweitner. Maybe you raise your hand a little bit, then we see who we are. Georg Garnweitner is from the Technische Universität Braunschweig, Institute for Particle Technology. And since 2013, he is a professor for nanomaterials, and particularly he is an expert for battery chemistry and battery technology in general. Good evening, Georg.
Hello, good evening from my side.
Then we have Manfred Hayek. Manfred Hayek is from the Technical University of Munich, School of Engineering Design. And since 2010, he holds the chair for helicopter technologies at that university. And formerly, he was in preliminary design and head of the development at Eurocopter Germany, which now is called Airbus Helicopters. Good evening, Manfred Hayek.
Good evening.
Then there is Bernd Korn. Bernd Korn is from the German Aerospace Center in Braunschweig, DLR, the Institute of Flight Guidance, and he's an expert in ATM, air traffic management. Since 2005, he's head of the Pilot Assistance Department and also is a lecturer at the Technical University of Dresden, and he is an expert in urban air system integration, UTM, that is the urban form of ATM, U-space, and urban air mobility in general. Hello, Bernd.
Hi.
And last but not least, there's Tomasz Krusinski from Airbus Helicopters. Since 2014, he's the Vice President in Research and Innovation, and he originally worked for Aerospace, which later on was Eurocopter and later on Airbus Helicopters. First as a design engineer, chief engineer of the X3 demonstrator. In between, from 2011 to 2014, he was head of the innovation lab of PSA in France. Hello, Tomasz Krusinski.
Hello, just one small detail. Manfred was my boss during a couple of years, so I have particularly important pleasure to be with you today, and I see my distinguished colleagues, and so it's really the pleasure. He injected us really the passion for innovation, and I am very happy to be with you this evening.
So you see, we also bring people together.
Okay, great.
Okay, so that brings me to our discussion round. I have thought we structure the discussion into two parts. Basically, one main part is on the technology, which is important, and the second one is rather on business and application of eVTOLs and air taxis. So I would like to start this first round with some key questions, I believe, and these key questions were also raised by this Uber Elevate white paper, and that is, first of all, performance, safety and security, and noise. These are certainly important aspects of these urban air mobility. And so the first part on performance, that's something we have to talk about first, maybe, because it is important to see how realistic it is that we can meet all these requirements set out by Uber Elevate. Where are we, or where is the status? When could we achieve these goals? And maybe just to cite some of these performances requirements, they set out a transport of 4 passengers or 500 kilogram cargo for 100 kilometers in several stages, maybe plus 20 kilometers diversion for emergency cases. Then a speed of 200 to 300 kilometers per hour. A maximum size of the vehicle of about less than 14 meters, fast charging of 600 kilowatts, and the availability of batteries with energy, specific energy of 300 watt hours per kilogram at least, and the whole thing with a maximum takeoff mass of 3,175 kilograms. This is a certain certification value for helicopters, and they wanted to stay within this mass. So this is a whole set of certainly challenging performance parameters they claimed. And my first question goes to Tomasz Krysinski. Do you think that these Uber requirements are achievable, and with what kind of vehicles? My question is, the background to this question is, earlier we saw something like multicopters, and now we see more vehicles developed with wings. First of all, do you see that these requirements are achievable?
Well, you know, in the life of the engineer, everything is achievable. So if you challenge the engineer, it's, you know, innovation and everything what is new is really the part of our DNA, and we have it Airbus in blood. So of course you cannot achieve, if I tell this immediately, I must move, and I have the brilliant professor in front of me about the equation of fluid, okay, which gives you power you need to hover, which is roughly inversely proportional to the radius of the rotor you put, okay. And actually, okay, and this is you cannot fight against the law of physics, okay. And we have roughly 300 different eVTOL companies over the world, and every day you have 2 more, okay. So the mortality ratio of this company will be very, very high. That I can tell you if you ask a question about it. But there will be, of course, somebody who will arrive to the end, and in many areas the basic equation of fruit is forgotten. Okay, and in this area that you need that to have something in hover, it requires quite significant power. So, and this asks you to have a quite significant diameter surface. Just that the induced velocity is quite moderate, and you can have a moderate power to hover. So for me, it's clearly you have to speak the performances. When I look on some of the design, I will not point out the design today. It's not the target, because as Airbus, we are very happy that so many talents all over the world are focused on this eVTOLs, and I think the fruit equation was manipulated by very few engineers in the past, and now we are very happy that there are so many people doing it every day. So it's really, and it's really a fantastic moment. Sometimes people forget really what does it mean, okay? And so, yes, I think it's achievable. Okay, it will require, I think, very specific configurations. Okay? And in the configuration, we should not only consider the power. Okay, we should also consider the complexity. Our aeronautics, that's not like the complexity. Okay, when I see some configuration with I don't know how many actuators, how many actuators in the system. And usually aeronautics, these actuators must be double or triple to make them redundant. So one moment it will be a flying actuator. So of course, the complexity is an important vector, which should be really mastered. And another item I would put also on the patent is the stable or unstable flying regimes, which will require very specific flight controls. And also it amplifies this complexity. So once again, the architecture, which will be the winning one, is the virtuous triangle between, let's say, performances, complexity, okay, and redundancy you must put to make it flying. Okay, and this is, I think, something what we should have really in mind.
And is what you say, is that leading to more vehicles with wings instead of the multicopters, which we saw in the very beginning? Can one say so in general, or is it?
Well, you put the wing is to have the low LVD in forward flight. This is the thing. But when you put the wing, you have the weight. You must put the propeller. So it's really the mixture. It depends the speed you want to test. So we tested several configurations already, which was a tilting wing with the CT Airbus. Our initial configuration. We have the propellers. With some kind of the 2 tons bronze, and now we have. I think the synthesis of this is our CT Airbus New Gen, where you have the wing, okay, and you have in this configuration also fixed propeller, okay, and yeah. I think it's not really, and I think we discussed with Martin many times, where the simplicity must be one of the key driver in the design.
Yeah, for sure. Yeah. Okay. So, thank you very much. Maybe I have also a question in this area, performance, to Georg Garnweitner, and that is relating to the batteries, of course, because batteries seem to play a really important role here. And again, there was this objective 300 watt-hours per kilogram This seems to be something which is not existing at the moment, but is it achievable from the point of view of battery technology? And how about things like degradation? I mean, new battery probably is different than one which is old, aging or charging in fast cycles and so on. Availability of materials, for example, ecology, prices. Are there any breakthroughs at the horizon? Will there be anything like particularly aeronautics batteries, specialized batteries or so? Could you imagine that? Could you say something about performances of batteries now and in the future?
Yes, thank you, Jan, for this question. I mean, you already pointed out very important aspects. Basically, I have to say I'm quite optimistic because we have an enormous amount of research that is performed in this field at the moment. And we have seen lots of developments in the last decades and in particular in the last years. First of all, I have to say we need to be a bit careful with the numbers, especially the figure that you have already mentioned, the so-called energy density or specific energy, where in this Uber Elevate paper, they mentioned the 300 watt-hours per kilogram. And basically, if you look at the literature, there are some systems where we are there already. But the big problem is that the reference is different. And most papers actually report their values regarding the cell level, which is basically the, let's say, primary unit of our battery system. However, if we then go to the so-called pack level, so far, basically, we have several levels of hierarchy. So from a cell, you go to a module, and then you go to the pack. And unfortunately, you lose quite a bit of this specific energy because, of course, we need additional components for safety, for stability, for the electric connections. And that actually renders at pack level the current values significantly lower. So currently, maybe we are at 200 watt-hours per kilogram realistically. However, there have been quite interesting developments in the last years, especially that the configuration is changed, how to get from the individual cell to the pack. So far, I have to say, involving materials that are a bit safer than the, let's say, state-of-the-art battery materials. But nevertheless, there are quite optimistic projections. And I think within maybe 5 years, we can be at a level where these 300 watt-hours per kilogram really are realistic. One has to say, on the other hand, for the operation in eVTOLs, we have several other obstacles and challenges. And in particular, what already has been mentioned, that we have a high power demand, especially for the takeoff and for the landing stage. Here, an additional problem is we are already at a rather, let's say, empty battery state. And so in the battery operation, actually the voltage somehow declines during the operation. So if we have a high power demand, it means that we really need an enormous current. And this is a problem for many battery systems because these high discharge rates, along actually with high charging rates, cause significant degradation. Mm-hmm. The thing why we can be optimistic is that, of course, also from the field of automotive applications, we have a strong trend to go to high power charging, especially because, of course, you want to achieve a fast recharge also of cars. And so there are actually many initiatives now addressing the issues that are, let's say, standing against such a fast operation of batteries, going to new materials, going to new architectures. And one has made quite a bit of progress in the last years to really identify what happens at these fast rates. And I would say still with the conventional lithium-ion technology, it should be achievable to get to this number and also have elevated discharge and charge rates.
Sounds good.
If we go to, let's say, regional aircraft, to some other aerospace applications, then I think one really would need to transfer to different battery systems and different chemistries. Within our excellence cluster, we are investigating in particular all solid-state lithium-sulfur batteries. because using these different materials, you would be able to store much more energy per weight of your battery system. However, the price of these more advanced battery systems at the moment is that they are not as stable. Of course, that a lot of more research has to be done in these systems. But I think also their progress is really visible. And of course, this will be on a longer time scale. Maybe here we are talking about a decade or 1.5 decades. But for eVTOLs, I think with the conventional lithium-ion technology, we can be optimistic that these values can be met.
Okay, thanks. Very interesting. I have one more question concerning performance that goes to Manfred Hayek. I put myself into the position of a layman. I am a layman. I'm only a acoustician. So I could ask this question, and maybe some other people would have a similar question. What I read is that the disk loading is a very important parameter for helicopters or for vertical takeoff and landing. And I think I've read that for the eVTOL configurations, we have a particularly high disk loading. And I don't know whether this is good or bad for the operation compared to helicopters. Can one say something about this in terms of performance?
Yeah, the disk loading is one of the elements, or one of the characteristic figures of vertical takeoff and landing aircraft, whatever type. It's valid for helicopters as well for VTOLs or eVTOLs. The higher the disk loading, the higher is the induced velocity, the higher is the induced power that has to be consumed. So first, I have to say it's a bit linked to your previous questions. What is it better to have a wing or only rotors or propellers? The higher the portion of hover flight in a mission of such a vehicle, the better it is to have a low disk loading, because the power consumption can be significantly reduced if you reduce the disk loading, which makes the rotor area bigger, which makes the whole aircraft bigger. So it's always a compromise we have to find. Now an aircraft, an eVTOL that is designed for missions of, say, medium range, 100, 200 kilometers or 300 kilometers, will most probably have a wing. As Tomasz said, it is increasing the L over D in cruise flight. It helps to be efficient in the forward flight section. But they all claim to be VTOLs, so they claim to be able to take off and land vertically on a limited spot where there's no place for an aircraft type landing. So they need rotors, they need propellers to lift off, and they will consume much more power if they go for a high disk loading. So this compromise is one compromise on power, but it's also a compromise on safety, because you cannot afford to lose lift when you are in the critical phase of approaching the ground or having just taken off there. Nobody wants to crash the aircraft just because, for whatever reason, loss of battery, loss of engine, or whatever, the aircraft comes down. So you have to design the aircraft to be safe during that flight phase, during the vertical flight phase. And you have to pay for it. You have to pay with a high installed power if you want to lift off vertically. And even if it's only 5% of the whole mission time, it is a critical phase. And it is something that the design will impact the design. Yeah?
Right.
So therefore, those many designs which have lots of propellers, lots of little propellers, or even tiny propellers, they need a high amount of propellers to create a certain redundancy. at another price that was already mentioned by Tomasz, which is the complexity. The more propellers, engines, and battery circuits you need to create redundancy, the more complex will the whole drive system become. So that is like for the conventional old-fashioned helicopter, the design of such an aircraft is a big compromise.
I see. Okay, thanks. Let's move to a second large key question. That's the question of safety and security. That's at least what I saw also in the Uber white paper. And my first question goes to Bernd Korn as far as this is concerned. I have many questions, and I believe many people have these questions. These eVTOLs basically will fly automatically or maybe later autonomously, as I understand, because people basically cannot fly them. How about the safety for a single flight? And when there is weather, and then when there is many eVTOLs around flying in a restricted airspace, like near a city, how does that work together with ATM or UTM? Is there a challenge which can be fulfilled, or is it a true threat? Is it difficult to meet these safety requirements?
Well, I would like to follow Tomasz' remark that a challenge. Of course, there are challenges, but as an engineer, we will face them and we'll find solutions. But yes, first of all, I think, especially from the operator side, we need an automatic transportation without pilots on board, and that puts all the requirements we have on the pilot, of course, on the system, and we are still, I would say, on the research side, we are on the way to overcome all those challenges, but to get that certified is another another challenge. But with respect to these safety aspects, we need as well to talk about the landing sites and the equipment we need there to get those vehicles down and get them out of the way to get the next vehicle down, because we are talking here about or we would like to have it as a mass transportation. So we need a lot of throughput on those vertiports, vertidromes, vertistops, however they are called, skyports. And there we need navigation technology, which does not really exist so far, in that sense that we do need an integrity, like a Cat 3 landing in the fixed wing domain. We need a communication with the infrastructure, with the automatic air traffic management system, because nobody can think about handling, I would say, an urban air mobility system with controllers as we do today with the air traffic management. There are by far too many aircraft in the air there. So all we are talking here about a very robust, very reliable communication system, which is as well secured against cyber attacks.
Right.
That's the next threat we have to take into account. We need to build in this cyber security aspects from the very beginning and not put it later on into the system, because then we might oversee a lot of, I would say, attack possibilities.
And let me ask you a provocative question, a second question on this. Will it take 10 years or longer than the actual technology to set up regulations?
Well, regulations are in place already, at least when you look at the UTM or U-space side of it. There we do have those regulations in place. We know how, what we call in Europe, we call it U-space, what kind of service needs to be provided, how it will be set up, what are the requirements for that. There are not many providers on the market so far that can do that. and the service is very limited. But basically, this kind of regulation is there. Where we see bigger problems is in the what I already said, in the vertidromes. How should they look like? There are examples there, for example, the Voloport or Lilium, or as well what you said, Uber or Joby now. They have ideas, but they are not really good for high throughput. They are there for, I don't know, for a nice environment, but nothing what we can really use for getting hundreds of aircraft per hour down and up.
In general, you would say
one thing to certify an autonomous operations, there we still have a lot of things to do.
Mm-hmm. But you would say that the safety or also security issues is not any form of showstopper which would take much longer than developing the technologies. So it is on the same scale time-wise as the technology for batteries for vehicles themselves. Would you say?
I would say yes, yeah. Mm-hmm. So we know what we have to do, but of course it's still a long way.
Thank you. I have another question, really going to Georg Garnweitner on the safety of batteries. Not as a layman, I could think of how do you control the state of charge while flying? It's very much more important than sitting in a car driven by batteries. Is that safe to control the state of the charge? And also, I'm thinking of fire or fire propagation in batteries. Is that a topic which is solved?
Well, it depends. I mean, getting to the second part of your question, maybe first. Of course, we have seen many problems with batteries catching fire. On the one hand, because in some cases, let's say too much energy was put into a too small volume. So companies were on the one hand trying to maybe save on some components, but also save on space and weight. And once, by any means, if the battery gets too hot, then you basically have reactions that are self-accelerating if the temperature rises further. And that ultimately leads to the fire in the batteries. One key problem there is the liquid electrolyte. And well, we will have to see. At the moment, there is a lot of research going from liquid electrolyte to solid state electrolytes. And these, in that respect, would provide much higher intrinsic safety. So that would be promising. But so far, the problem is that most solid state electrolytes either have problems in the processing or have problems that the ionic conductivity that we need, of course, with the lithium ions traveling back and forth, is too low at room temperature. So you might need some, let's say, clever thermal management, which, however, for the eVTOL operation, I think we need anyhow, because we have some stages at high power, where then also, of course, high temperatures would be generated. So in that case, it might be an option to already, let's say, have an operation at higher temperatures. That might also be, let's say, easier manageable. And of course, I would expect, but basically I'm also a layman in these applications, that it would be worthwhile, let's say, to use more high performance components and not the cheapest ones. That maybe also would provide then a higher intrinsic safety.
Okay.
As for the state of charge, this is definitely not an easy question. I think that, of course, with many different battery systems appearing, the problem is that there is no, let's say, uniform method to determine these key factors. But on the one hand, there are lots of research activities at the moment going towards the different systems. At the moment, let's say, the major problem is how can we implement such methods into a practical application, because it's not only the voltage that we can take to determine the state of charge. especially if we have high power operation in between, because then, let's say, some additional reactions might be going on, some additional effects. And I even think for aerospace applications and also for eVTOLs, we might have to go to a solution where we use two different types of batteries in our system. Some that are easily capable of providing high power, so that could be used for our takeoff and landing phase, and others that provide the high energy that we would use for the cruise state. I think this is quite probable, and of course, then the analytics to determine the state of charge for these kind of individual systems would provide a bit more complexity. But there is a lot of research, so I would be optimistic that also solutions could be found for that.
All right. Okay. Let's come to the point noise, which I'm particularly interested in. And this question goes to Tomasz Krusinski. It seems that at the moment, there's not very much information, not much data around from the manufacturers so far. They give here and there some data, but measured in different ways. So I think there's not a good overview about the noise. Do you think the noise requirements of Uber, which say that in an urban environment, the noise of these vehicles will be masked by the background noise, is that achievable?
I will not. I will, let's say, confirm what I put in the introduction. In aeronautics, our excitation, our passion is for the things which are difficult to achieve. And one thing I would like just Jan to be a bit correct. That helicopters are not noisy and are not expensive. Okay. Because, we did a lot of studies of noise, and we have introduced very specific blade shapes. We did it with Onera and DLR, okay, and it is really something what is really extraordinary, this cooperation with research centers. And I was just yesterday, on the landing field on H160, where a completely blue edge concept, okay, of the blade, and it's a completely new helicopter when you hear, let's say, what is going on. Okay. And
so why do we need eVTOLs?
Yes, well, we are doing eVTOLs, but we should not forget, that helicopters are still there. Okay, and we did a very significant improvement in terms of the noise. Noise, of course, is a key aspect. So we don't publish much, but as you know, we have a very big ambitions for the noise. And recently, in our research center, we tested 8 kinds of blades for the noise, in terms of the number of the blades, the shapes, the profiles. So it's really optimization of the noise is something really which is a key. So the noise is, of course, one of the important items is the tip speed of the blade, which is the Mach number on the tip. So lower you turn, less noise you have. And the UAM, of course, and this is a bit contradictory to the performance. Okay, but if you turn it slowly, you must have a local surface. It's heavy. So it's still this compromise that we love in aeronautics, where to put, the threshold, okay, in there. Yeah.
Right.
And also, what is also challenging for the eVTOLs, then when you have 8 sources, 8 rotors in hover, you have 3 dB from each sources.
Mm-hmm.
Okay, so the challenge is still, significant, but well, with all the effort we are doing in modeling, all the effort we are doing in really working on the blade tips, I am quite optimistic that, 65 dBA will be achievable. And well, for us, a helicopter does not make the noise, it is the music, okay? Okay, and the issue is, or the question is, for people who don't like this music, we must make the eVTOLs, below the level you hear it. But it's just for people who don't like helicopter music,
Yeah, I know.
This is, you understand what I mean? And this is, something extraordinary. But once again, it's still a lot of challenge. And 20 years ago, having the blue, blue edge concept, you know, what we put on recent helicopter, people thought it was not achievable. And we did a very extensive study with DLR on it. And now this dream from DLR, we make it industrial and put it in real life. So right. I am very optimistic once again. Naturally, I'm optimistic, you know, for this. So, okay, it's a challenge, a lot of sources, but also a lot of innovations in terms of the profile shapes, the tip, and also what is also important that one item we should not forget, the electric motors have something magic. You have very quick access to the torque. Yeah. And you can make working your blades closer to the stall. Okay, so you can turn them slower than, let's say, something when you have, let's say, piston the turbine engine due to the governing system, which is a bit slower. So you have some inconvenience and advantages, like always. In aeronautics, we must choose the compromise in the virtuous triangle, performances, okay, noise, and the complexity. And this will be, people who will manage it will win the war. But this is noise, I think, despite the performances, is really the most important item, and at Airbus, we took it seriously into consideration. I explained you, we did a lot of testing.
I see, yeah, very, very good. So in this first round about the technology and feasibility, it seems to me, so far, we do not see really strong showstoppers or so. It looks like the technical feasibility is on the horizon at least, and maybe we can start our second round about the business and application. And what I see as a layman is it seems that extremely much money is invested in these startup companies which build these vehicles, like Joby, like Lilium, like Volocopter, and so. So far, I think they've never earned any euro with it. So far, they've just spent money. But there must be a true business case. Otherwise, those investors would not put so much money into it. That's my logic, at least. So, approaching this business case or business application, I would ask the question, maybe again to Tomasz Krusinski, what is a typical air taxi mission? Just to get an impression of it. What would one do with an air taxi?
Well, it's, you know, it's you cannot have the long range vehicle, you know, with the batteries, and clearly, so it's something would be considered, the range is below 80 kilometers. Sierra Gamma is designed for it with the speed which is 120 kilometers per hour. You know, sometimes our colleagues want to make it quicker, but the mission, it should be something reasonable. You know, you have also some margins, but it's clearly in the reasonable time horizon. It's something what allows you to link the airport to the center of the city. Okay, and this is if you have 80 kilometers of the, let's say, range, it's what covers most of the applications.
Ah,
okay, and then somebody in the missions was speaking about the payload and the sensors. Yes, I think it's Bernd who was pointing it out. And one thing, you know, when you speak about these missions, we live now the revolution in the sensors. And this is really will bring really the important value for the eVTOLs, the sensors. We have the leaders, radars, you know, cameras, okay, which really allows to catch all the environment, you know, coupled with the fly-by-wire system, and it will open the doors really for the autonomy. And this is something important of the mission also. You know, we can, it's difficult in the far future to have a pilot to transport 4 people, you know, and clearly autonomous flight, which when we leave this revolution of sensors, and this revolution is not only sensors, the size of the computers, you know, the computer power, we can use the sensor fusion, we can use let's say all the image processing, SLAM technology that you can reconstruct everything what is around the aircraft. I think it's this. If you speak about the mission, this will ring really the value and the pilot. One moment, okay. Of course, will not be necessary.
Yeah. Another question, a little bit related to that, and goes to maybe first to Manfred Hayek, is it's a bit provocative. Is the air taxi transport useful for European cities? I have a bit, the background to this question is I have a bit the impression this was not by chance when the idea was invented in the US, in the North American cities, because they have a bad public transportation system in their cities and they need something. While in European cities, I would claim we have a relatively good public transportation system. Is it of any use for European cities?
So there are two answers. There is a short one and there's a longer one. I skipped the short one. The longer one, for the longer one, I have still to again to address two topics. One is performance, the other is safety. Regardless whether you fly over one of the Asian megacities, European or whatever city, people require, they will insist on a safe aircraft, and not only people, but before that, the aviation authorities. But safety is also a product. Safety is a product of design. Safety doesn't come just by itself. And let me step back quickly to the battery. It was a simple lithium-ion battery that managed to ground the whole Boeing Dreamliner fleet for weeks. A couple of years, I think 6 years ago, because it started burning. Guys were lucky because the aircraft was somewhere in Japan on ground. And Boeing was forced to find a new solution, a brand new, different solution where it could be demonstrated that the battery would be safe. Now, a safe battery, I'm not an expert at all, so this is Georg Garnweitner much more, but I look at it from the safety point of view. Nobody would accept an aircraft, and even if it's a small one like an eVTOL, where there is a story somewhere in the media that says this aircraft has been lost, and as well as the lives of the passengers were lost just because the battery wasn't good enough. And if we didn't talk about failure rates, the public and the authorities will request a failure rate. Now, it will depend on the size, but just to give a number or numbers, if the authorities are happy with a catastrophic failure rate of 10 to the power of 7, minus 7, that means a catastrophic failure is allowed to occur every 10 to the power of 7 flight hours. That is approximately 1,141 years. That has to be demonstrated. This is not, it's not enough that you get a sheet of paper from the battery manufacturer. It has to be proven. That is one thing. The other thing that is responsible for safety will be what we call avionics. And here I'm much less optimistic than my friend Tomasz. Because I still remember, and I won't forget, the time we needed to certify an aircraft with lots of software on board, like NH90. NH90 is an aircraft that is neither autonomous, it has a fly-by-wire flight controls, but it doesn't fly autonomously. It has a pilot, two pilots on board. It has tons of software. It is the order of magnitude, it's not a correct figure, but the order of magnitude of 10 million lines of code. Now, imagine you want to put in service an aircraft, a small eVTOL, which is flying autonomously. How should that amount of software, that with the same criticality, because it has to be safe software, with additional functions using all these nice sensors and providing the function of autonomy, when should it be available? So if it is done one day, I think the air taxi transport is feasible. I don't doubt that one day there will be air taxis. It is technically feasible, but now, end of the long answer, is it useful for European cities? It will be a very expensive aircraft to be a supplement to the public transport in Europe. I don't really see a market for that. I don't see a real market. I don't see it is worth investing lots of money, and the money that has been collected so far is not enough to reach these targets that will make these aircraft safe enough.
And how about American cities, for example, North American cities? This is a different picture, would you say?
I would start with New York. The people in New York, they have demonstrated violently after the first accidents of helicopters in the, when was it, Tomasz, in the I think it was in the 60s or 70s.
Yes.
There were helicopter shuttles from downtown New York to the airport. The first aircraft fell down, and the New Yorkers said they don't want any more helicopter above their heads. There was an accident, I think 2 years ago or last year, which was relatively harmless. It didn't fall down on Broadway. It was a landing attempt on a rooftop, and it came. It fell to its side. There was I don't remember the reason for that, but it was reason enough that the people again expressed their opinion against vertical takeoff aircraft taking off from the rooftops. So to gain public acceptance will be the major task. So beside all those technical things and challenges, it will be a major difficulty to convince the population in a city that this is a good idea. And a bad reputation is not good for the business of an operator who wants to sell flight hours for his eVTOLs.
I know this topic exactly from acoustics also. The perceived noise is different from the physical one, and the perceived safety is probably also something which is different from the actual safety, right? So I would also think that this is an important issue. Yeah, I understand. Maybe the last question I would have goes again to Tomasz Krusinski, and it is about cost. Not cost for the company, but cost for the user. Is there any estimation so far what, say, a ticket with the air taxi would cost in relation to a ticket with, sort of, for example, the metro or a standard taxi when I want to get across the city? Like I want to trip across the city, how much more do I have to pay for the time I save?
Yes, Jan, I will not give the numbers, but first thing I fully support Manfred, you know, what he was telling. I take now a bit more stronger approach. So for eVTOL, all the sensors and everything we're doing will have the cost and the weight. Okay, this is very important item. And if you compare it to the automobile industry, you know, in the autonomous car, When you have the problem, you can just stop the car. When you are in the flight, it's completely different issue. That's Manfred was pointing out, redundancy and all the complexity. It comes very quickly. So in this area, I fully support, this situation. In terms of the cost, I will give you the number, but I will just compare the aircraft eVTOL to the car.
Yeah. Mm-hmm.
Electric car in the city, you can drive for people with 40 kilowatts electric motor. To put 4 people in a hover, you need 10 times more.
Mm-hmm. Mm-hmm.
Factor 10.
Okay, I see. Okay.
So if you consider, of course, what is the cost, proportional? Is it linearly proportional to the power? Probably no.
Mm-hmm, mm-hmm,
but let's say if somebody tells it will cost like a car for the same distance, it's absolutely no.
I see.
You understand? So the response is really by the comparison, and of course, this aspect of the power for electric drive system is important one. And the second, of course, is the redundancy of these actuators. If we have them, all these elements we have around, it would have also the costs, and it must be much more redundant. There's often misunderstanding comparing automobile to aeronautics. Okay, people think, okay, you are in there, it's much easier. It's absolutely wrong, because if you are in the air and you have the bad weather condition, you have sensor losing, and you have people involved, you must land one moment. So everything must be redundant if you want to certify in the probability of failure Manfred was pointing out. So I think it's a message I want to carry.
What I wanted to ask with this question also with cost is, I know at least that these current helicopter taxi services are really expensive currently, if you use such a service. And the question is, would such a system be less costly compared to what you would spend for a helicopter taxi service today? When I compare that, is that something in between, say, a car and a helicopter service, or is it comparable to the helicopter service? Or
well, it's really depends much. Okay, on all the elements were put on. I think we don't have, we cannot state the clear response, because batteries, if you take them today, they are expensive, especially with the qualification for aeronautics. We pointed out the fire of the batteries, okay, and this is still it's something really what should be solved. So we see also the curves of the batteries, which are given battery supplies, which we will fall down in the future. Like in automobile, okay, we have electric motors. We are still improving. There are a lot of technology we can get rid of the magnets, which are very difficult to acquire and expensive components. We have the engine. Where we have that they winded rotor, and it is. Was asynchronous engine where you don't have any magnet, we have everything in standstill. So it depends how this technology will move, and the cost will be directly proportional to it. Then we have also all this technology of ILM, that you can produce the fuselage and all the parts in a very quick and cheap way, which still to be certified. So I think it's very difficult to predict now, let's say, the real cost. I believe that also the automobile production technology will come in some areas, so which we could, if you have the quantity, lower the costs. But from other side, we must have still aeronautical qualification and the quality, which is a bit different aspect. So it's a bit equilibrium. But I still give the number, but I compare it to the car, in terms of the power.
I see. Okay. Thank you very much. I think as far as time is concerned, we are a little over time already. I would really like to give the audience the chance to ask questions to our experts. Mr. Höfner, could you tell me which was the first question, or whether there are any questions. Okay, I see in the chat. I see a question. I don't know whether I have the right one. Okay, this is a question from Mr. Yanev. Mr. Korn mentioned that tilt rotor eVTOLs will be having problems in integrating to the use space. What are the main drawbacks of the tilt rotor eVTOLs compared to fixed rotor in terms of controllability with respect to fixed rotors, and how would it affect their certification timeline?
Yeah, so from my point of view, I already answered that question in the chat. So I did not mention that there's basically no difference from the integration point of view. So maybe that was a misunderstanding. The other part, I would like to give the floor to somebody who's an expert on these aspects, certification of tilt rotor with respect.
So I can give some elements for it very simply. You know, when you have the tilt rotors, we have the triplex system to tilting the mechanism.
Mm-hmm.
You know, you have, and this is quadruplex, is triplex, you know, actually what is done. So, of course, it's complex. Okay. You have also this intermediate regime between the hover forward flight, which is, let's say, a bit delicate transition phase. Okay. So, it's clearly this will be more complicated, more expensive than the completely fixed version. Perhaps the fixed version, we have a bit less performances. The compromise, the hover and forward flight is be a bit more delicate, of course, but let's say it must be once again the equilibrium, okay, between the complexity, cost, and the performances. Huh?
Yeah.
And tilt rotor have some, of course, these stages between the hover and forward flight and also the tilting mechanism.
Right. Right. Okay. We have another question. Yeah, it is expected that the eVTOL aircraft would have different energy reserve requirements than current helicopters in 20 minutes. Certification, this can influence the choice of configuration, since 20 minutes with 240 kilometers per hour, Joby and Archer, is a lot more reserve energy and respectively battery mass, maximum takeoff mass compared to 120 kilometer per hour cruise, which is the City Airbus next gen. Mm-hmm. This is probably a question for Tomasz Krusinski.
Yes, you know, it's once again is I think Joby is a tilting mechanism. Okay, mm-hmm. So you have a bit worse performance in hover, and you have a bit better in forward flight. Okay, in hover you must have a low twist on the blades. When you tilt the mechanism, you must have high twist to go to the forward flight, and the compromise is a bit delicate. Okay, and of course in 20 minutes it's enormous for eVTOL, because it's more that what they can fly in terms of the batteries. Of course, it must be less than that. We must have the safety margin. On the CG Airbus new gen, we put a bit lower speed. Okay, because we want to make the simplicity on the vehicle. Okay, no tilting mechanism, so less weight, less complexity. Okay, easier certification, and this is why it is a bit different. But of course, the requirements on helicopter, you know, is 20 minutes, but we have usually much more, because we have also the fuel in the reservoir, and it's really. It's not the problems except end of the mission. And in the eVTOL, of course, range will be limited. I told about 80 kilometers with our design pod, and now the question, we must recharge it very quickly to make it, let's say, the business case, the target, really working.
And that's one question which is interesting, and I would first pose this question to Mr. Hayek. And that's a question from Rotors. So how will the downwash of multiple vehicles be handled for mass transportation when concentrated at vertidromes?
Yeah, thank you for that question, Hero. So that is really, so first, it is not yet answered. That's why you were asking it. And it is a real question of concern. And I would add some effects like the flow around buildings, vertiports, whatever landing spots we have that might interfere with the downwash of these aircraft. So it is clearly a matter of current research, and we were, so at my chair, we were lucky enough to get a funding from the last LUFO call, where we investigate the interference of external flows coming from building turbulences into the rotors of multicopters. Because nobody can say today how we interact, and we will use some of our experience of current work that we currently perform, which is pretty similar, which is the effect of downwash of the helicopter on a moving deck of a ship. And we had to learn that this is a pretty tricky task. Yeah. So the downwash of the helicopter will act back to the helicopter. It will be perceived, it will be felt by the pilot, depending on the distance to the ground and to the inclination of the ground plane. And we have a partial ground effect once the helicopter is only partly over the ship deck. And when the ship goes at a speed of 30 knots, which is not that high for a military ship, there is a huge field of turbulence, which is also coming in. So those two effects are still to be studied. It is, it is the beginning of research. And until this is not clear, that the authorities, now I'm back to the authorities and the safety aspect, what they can do is either to limit the number of aircraft or to separate the aircraft and to request, like it is the case at airports and for large aircraft, they will make conservative requirements. They will impose very conservative requirements so that the probability that an aircraft gets into some uncontrollable state is minimized.
I have a question relating to that. Maybe the revolution of sensors has been mentioned. Would massive use of sensors help to make this vehicle intelligent and react early enough in such situations, as earlier than any pilot could do? Is this thought, or is it not feasible?
Theoretically, it's feasible, not now, and not in 10 years. This would require, if you imagine what it takes to measure the flow field, even if it's a controlled area like in a wind tunnel, it is a huge effort. And specifically those flow environments where we have turbulence, we don't have a regular flow, so it is more or less unpredictable.
Right. Mm-hmm.
And I'm not member of the party that simply says, okay, we will put some deep learning and some machine learning into the system, and this will do it.
Yeah.
No way.
Yeah. I see. Okay. I just thought about it. We have one last question, which everybody we ask to answer. I have one more. Okay. But one is from Yannick Heusinger. When would you expect the first air taxi service worldwide to be available? and he would like to have a guest from each of the experts. So maybe we start with Tomasz Krysinski.
Well, you know, I will give you a bit a different response. I was in Silicon Valley 6 years ago, and I was informed that the certification of a taxi would be 1 year later.
Oh.
Okay, we are in 2022, and it's not the case. And we, of course, we must first make the vehicle, and we want to fly our CG Airbus new gen next year, or even get the certification to get 2 years later. But then you have much infrastructure, and you must have all these things which are still not existing. So it fully service, it will be still a way to go.
Okay. Manfred Hayek, what would you guess?
Yeah, the first air taxi service, wherever it will be, I don't know where, will be available in less than 5 years. The first air taxi service where people are making money with will take, in my estimation, at least 50 years, 50.
Wow, interesting. Georg, Garnweitner, what would you say? Maybe a little biased by the electricity or by the batteries.
Yes, well, I mean, of course, what is really tricky for me to answer is how the aspect of safety of batteries really can be resolved. I understand this is, of course, a very different story compared to the automotive industry, where, let's say, some accidents, some fires kind of happen and are more or less accepted. So it's tricky to say. I think from the battery perspective, the big problem is how long can the batteries be used? Because we see for these high discharge rates that really the lifetime goes down. So yeah, it's maybe a bit like Mr. Hayek said, that there might be some demonstrators quite soon, to my guess. But really to make money, to be able to have a, let's say, sustainable lifetime of these batteries, that will require significantly more time. And I also think this is rather a matter of some decades.
Okay. Now, Bernd, you tell us when we fly with air taxis.
I don't know, but the real operation, well, with this automatic transport will take a decade, definitely. You know that in Paris they plan for the Olympic Games to have piloted transportation, but that is not the, I would say, the type of operations we are dreaming of, or we are hoping for, or looking forward for. So that will take a decade, I guess, at least.
I have two last questions. Well, the first one is from Rolf Radespiel. That's a long one. From the previous discussion, we take that weight of eVTOLs matter a lot. Now I heard about batteries, system complexity, ATM integration, noise, but there was no mention about weight reduction technologies. What is needed here, and what is possible with respect to materials, function, integration, and crash? Materials. Maybe this is a question going to Tomasz Krusinski. Is materials a topic for you currently?
Well, you know, in all this eVTOLs, Airbus, we are the only to make the real size vehicle, 2.2 tons, CG Airbus Alpha, to really carry 4 passengers. Huh? So battery, you know, is 1/3 of the mass. We must have put all the system, the fuselage, and so on. So clearly, power density is a key driver of it, of the density of the energy. In the car, okay, if you have the fuel car, for 1 ton car, you have 30 to 40 liters of fuel. It means 3%. Immediately, if you go to the same electric car, the weight is 1.5 tons. It's much heavier, and the battery is much heavier. Okay, really, the improvement of the energy density is the first important element, which is really the key driver. The second one is, of course, everything what, if you go to this multi-rotors and we multiply number of rotors by 8 and the blades, we must have really low weight composite blades, and we must have low weight electric motors. Because you multiply it by 8 and you have 3 blades. If you don't want to have the noise, you have 3 blades, you multiply 8, you have a lot of blades, 24 blades. So if you save 1 kilogram per blade, you know, you have, let's say, in milliseconds. So really, optimization, and it is extraordinary challenge for the engineers, the mass optimization for the fuselage, for the batteries, for the electric drive is really the challenging stuff. And I strongly believe in, for the fuselage, in the ALN technology, clearly. For the batteries, I hope to the significant improvement of the density in coming years. And we saw what happened in the automobile industry, where the cars were autonomy very low, and 10 years after, you know, it's completely different. And of course, this is still much more important for eVTOLs than for the cars, you know, due to this, all this fruit theory and the physics of the behavior. So yes, materials optimization, and well, and you have the wing, and you have 8 rotors. Baby big starts to be big, yeah? And the fuselage starts to be heavy, because you must tune it dynamically. You must have frequency which are not so low. You must have the notch filters in the flight by wire system to control it, so the frequency cannot be too low. And that's what makes, I think, global optimization for the aircraft and the challenge for engineers very interesting.
All right. And our last question is addressing winter operation. Is winter operation an issue, like cold, snow, ice, and so on? Is this something one would say that winter operation is excluded for some reason, or is it feasible?
You know, Manfred has opinion on it. Go on, Manfred.
Please, Mr. Hayek, please.
So, winter operation is something that batteries don't like at all. I just realized, because I, by chance, have a hybrid car with a battery. When it is charged during winter, the range which is indicated is much less than the range that is indicated in summer. So there has, and this will impact anything from the available energy to the available flight reserves, etc. And as for any other aircraft, the certification of the battery will have to be done for the whole range of temperature. There was another item mentioned, ice. There will be no flight in icing conditions with such a vehicle, because icing or anti-icing systems are only available and they only pay off for very large helicopters, like those operating in offshore conditions in the North Sea, and they are really large aircraft. They are the 10-ton class. So I don't think it will be ever realized that an anti-icing system will be available on an eVTOL. Would make it just more expensive. Another item which just comes to my mind is heating of the cabin. The attractivity of an eVTOL. Imagine all those videos and all those presentations that show smart people entering the eVTOL. They are brought from A to B. They have nothing with them except their credit card or their iPhone. Entering in winter into such a system and let it take off at temperatures around 0 requires heating, which makes this thing even heavier, which consumes energy. So it is I think in most of the designs that I have seen, the winter operation has not really flown into the final takeoff weight of the aircraft. Yes.
Okay. Thank you. Anything to add on this question? If not, then this concludes our round of discussion, the Q&A part, and I would maybe conclude that we have seen that there seem to be no real technical showstoppers for this for the eVTOLs and air taxi vehicles. Whether it will be, well, it will certainly not solve the traffic congestion problems in big cities. But the question is whether there will be an economic market for it, whether it will stay as a niche market or develop into something like a mass market. And what I see from the discussion is it's probably much too early to draw conclusions on this at this point in time, because we are in the midst of a development phase of these vehicles, and many things are evolving fast. Battery technology, sensor technology, which may play an important role. And maybe this is just a status in between. We cannot predict too much for the future, but I think we are all pretty sure that in a few years we will see those vehicles flying. The question is, really the central question is what is the business and the market for them? I think it was not expected that we can answer exactly this question in this discussion, but maybe it helped you to think about it and to have some thoughts about it. Let me, at the end of this forum, thank again very much our partners discussing together. It was very interesting and insightful for me, at least. Thanks for your thoughts, all of you, and your willingness to participate in this discussion. I found it very interesting, and to the audience, thank you very much for your interest and your time. Goodbye.
Goodbye. Thank you.
Thank you. Goodbye.
Thank you, everyone. Goodbye.
Bye-bye.